The news often highlights new and ongoing restoration projects, many aimed at revitalizing, improving, and beautifying neglected and degraded streams in urban areas. Communities whose streams were once engineered into submission are now looking to reconcile the long severed bonds between streams and their surrounding ecosystems. So a very interesting question arises. What causes a stream to become degraded in the first place? Hi, my name is Keitasha Royal, and I'm a PhD student in the Hydrologic Sciences graduate group at UC Davis, and I'm researching urban stream geomorphology. Let's talk about the urban stream syndrome, a mechanism that may help explain the degradation of urban rivers. But first, let's step back in time. Human modification of streams is nothing new. Streams have provided economic, cultural, and political resources that have helped propel civilizations for thousands of years. In America, the fertile soil deposited by streams made for landscapes sprawling with agriculture, many made possible due to the canals, ditches, and dams built to divert water. Additionally, the streams themselves were used to power industry. By the turn of the 20th century, an industrializing America brought about a wave of urbanization. Landscapes once dominated by manufacturing buildings soon gave way to high-rises, connected by increasingly impervious surfaces. All the while, streams became vessels to carry waste and overflow far away from cities. It is here we have the basis for the urban stream syndrome. Though the term emerged in 2005, researchers have been documenting changes to urban stream ecosystems for over a half-century. In general, the urban stream syndrome describes the observed ecological degradation of streams that drain urban land. Though streams may be affected by multiple interacting stressors, a main driver of the syndrome is surface runoff. During a storm, impervious surfaces like parking lots, sidewalks, and roads prevent water from infiltrating into the ground. Instead, runoff quickly collects in gutters where highly efficient drainage systems dump runoff into the nearest stream. Why is this bad? Let's take a look at what's in stormwater runoff. There could possibly be industrial waste, oil, pesticides, de-icing salt, and sewage overflow, and that's just to name a few. All that making its way into our streams, that's not going to go well. So what happens to the streams? Well, a syndrome is a collection of symptoms that occur simultaneously. The symptoms for the urban stream syndrome can be broadly characterized into chemical, biological, and physical/hydrologic impacts, which in return can be further described by more specific changes. Let's turn to the chemical impacts. Many streams see an increase in nutrients such as nitrogen and phosphorus, as well as an increase in mean water temperature. Biological changes include a decline in sensitive fish and invertebrate species, while chances of eutrophication increase. Hydrologic/physical changes include faster, more erosive flows, which in turn impact channel morphology, making a stream wider and more incised. Let's see the physical and hydrologic symptoms in action. Without the ability to adjust to different stream flows, storm water will erode the banks of the stream, widening the channel while scouring the bed, causing the channel to deepen. Though streams may show similar symptoms, expressions of the urban stream syndrome are not universal, and understanding these differences is key. Regional differences in urban infrastructure, age, timing of development, and historical land cover can affect stream responses to urbanization. Therefore, addressing a stream's symptoms calls for management approaches tailored to that stream's physical and social context. Simple, right? Well, not so much. Many questions arise as to the best path forward in addressing the urban stream syndrome. Researchers of all backgrounds are invested in how to best address the urban stream syndrome, from geomorphologists like myself to ecologists, sociologists, and urban planners, to name a few. Continued research is necessary before general assumptions about urban effects on streams and their ecosystems can be made. Also, more work is needed to find the best approach to treating the underlying causes of the urban stream syndrome as opposed to just treating symptoms. Ultimately, the goal remains that behind the headlines, there are healthy urban stream ecosystems in our communities.